Some of these speeches I do, sometimes it's full, sometimes it's not. First thing I want to do is it's unusual for this event. When I speak, I normally get 1 or 2 people try to connect to me on LinkedIn or email me. I reckon I've had about 50 or 60 from this event. I started off saying apologies to some of you that I couldn't meet you. I'm going to do a blanket one now saying I'm really sorry because I've turned up, I'm presenting, and I have to leave because we've got so much going on in the factory. So apologies to anybody in here that did ask for anything. So that's my first apology out the way. So, Matt Harris, head of IT. Just put our objectives as an IT department up there just for a second, but very simply put, as an IT department, we have probably 2 or 3 different hats on. Our normal day-to-day hat, like anybody that works in IT that's in the room, we have to just make sure that the lights are on and everybody can get on and do their job. We have some very specific challenges which I'll go into with regards to trackside and the specialist nature of our business, but we do just about anything and everything the rest of you will do within a normal everyday business, whether that's your IT support, we do high performance compute, we do our ERP and our PLM systems as well, so I'll talk about that all the way through. But really the biggest thing for us within our department is that we've got an incredibly technical, capable and competent set of users. Generally, when we turn around and have issues with our users, they're a bit cleverer than probably my first or second line support in many cases. So that gives me a slight challenge that they're generally trying to jump the queue for support all the time. We have to provide a very agile, very robust set of infrastructure at the track. It's not like you can probably imagine. I'll try to describe it a little bit over the next few slides. And I'll go a little bit into how we use data, both track and factory, and how we're trying to move that forward. So if I start at the track for a second, it's the most visual part that most of you in the room, if you're into F1, who understands and likes F1 in the room, just for a second? A lot, okay? I've done that in the States before and ended up making a joke about we turn left as well as right. But so from a trackside point of view, we have what most companies would like to leave in a nice air-conditioned branch office, if you like. We take around half a ton of IT equipment in a couple of racks. Those 2 racks have to basically turn around and enable the business to run at the track in a completely isolated fashion, worst comes to the worst, but they also have to turn around and connect everybody that's at the track back to the factory. There's a number of different rules and regulations that have been brought in over the last probably 7 or 8 years. Every time I say a date, probably times it by 2 or add a couple of years because I forget. I've been there 19 years, so everything sort of blurs into one a little bit these days. But those 2 racks of equipment, I send 2 guys around the world, and they look after that equipment from setting it up during the setup of a race week. So it depends whether it's what we class as a European event or a flyaway. They have around about 36 hours, roughly, of setup work before everybody else in the team turns up and expects to work like you would every day in a branch office. So whether that's using your basic services of email, internet, but they're somewhere different in the world, either every other week or, worst case, every week. Okay? So for us, the challenge is to turn around and give them the same environment in 20 different countries over the space of about 44 to 45 weeks. We have tests and everything as well, but we tend to ignore those because everybody thinks they're simple. They're just another event that we turn up to. So, sounds simple, setting up the infrastructure for 36 hours. If you think about the size of this room very roughly, that's about the size of, well, it's probably bigger than the garages in a number of places. If you think of this room with the car set up to run, the IT equipment basically is stuck in the middle of that room. You might have people that are using carbon fiber, fixing maybe parts of the car or adjusting them. So I've got carbon fiber dust in the air. I might turn around and go to Singapore and I have maybe a 60 or 70% humidity. So now I've got carbon fiber and I've got humidity and I've got IT kit that's got no air conditioning, it's got only us filtering the air. So anybody in the room can work out that that's probably not a few things you want to be putting together for a reliability point of view. You might then go to somewhere like Bahrain, where we have a very dry, dusty, arid environment, sandy environment. Again, not a great environment for the IT. Sometimes this will be 40 to 50 degrees air-in temperature. So, number of people in the room, well, why don't you air condition it? Well, what happens when air conditioning fails? The kit then overheats. So I have to engineer for the worst possible situation, which is I don't have air conditioning. So then actually, I just run the kit all the time from that. We run then for 4 or 5 days at the track. 60 to 70 people at the track. 60 people are allowed to work on the car at travel with the team and work on the car. We have a few more that travel over and above that around facilities, so catering and marketing and a few other areas. But those 60 people expect to work as though they're in the factory, whether that's getting their email, their mobile phones, their telecoms. After we've worked for those 4 or 5 days, we take 6 hours to take everything apart, make sure it's as pristine as possible, transport it to the next world and then do it, the next country and do it again. So, sounds simple, but if you were to see it, it's a bit like an old school comedy sketch where everybody is pulling cables down while somebody's up a ladder. Health and safety wise, it's probably not the best environment, but it's one of those things we have to do. The challenges we have to work with, it's a slightly different challenge to what everybody else in the room for a normal IT business would be doing. A few of the stats on there that are just the 176 time zones crossed. That's because of the fact that they don't ever let us go around the world in one direction and just keep going around. We keep going backwards and forwards back to the UK or in between other countries on the way. The 170 nights away, so the 2 guys I said that I send to most events during the year, I see them probably for 3 weeks of a year. And that's the amalgamated number of days, because by the time they've flown to an event, set up, run the weekend, come back, had a bit of time off, flown to the next event, I only see them really for 15 working days a year. It's an astonishing number of miles that the guys that travel. As you can imagine, most of them end up with some fairly good gold cards and stuff from fairly different airlines, but it's an astonishing amount of time away. The other thing about this mileage is that I have some very, very strange decisions I have to make. Most of you, if you turn around and you wanted to buy 7 printers to cover the 60 people at the track, you'd buy 7 printers. I actually end up buying 56 printers because it's cheaper for me to have 7 sets, sea freight 6 sets around the world, than it is to air freight 1 set all year. That's because I always used to say Bernie. I have to say Liberty now, because we end up paying Liberty around about $300 per kilo to send the kit around the world. So I now have a weight conversation rather than necessarily a cost-effective or a lifetime. Some of those printers will work for maybe 10 days a year. So every time I get them out of a sea freight box, I've now got a different issue, which is they've been sat in a cardboard box for several months, actually haven't worked. Just some strange differences for you all. So, data. Some of these slides are slightly out of date already, and they're only about 2 months old, because we're forever changing what we're doing. We're forever improving what we're doing. So, some of the stats on here. So, if I take an example of a race weekend, when a car's going around the track, our limitation is actually the ECU, so the controlling box that's actually part of the legality rules and defined so every team's the same. That box has a limitation, and its limitation is actually the flash memory speed that's inside it. That's for both writing and for us to read off. So we're always playing a little bit of a game about how much data do we need to have, how much data do we want to have, how much time do we want to spend offloading that from the car, so that when you come to qualifying, you've got enough information to making a data-driven decision without it taking 5 minutes to offload from the car. So a lot of you put your hands up and you'll know that 5 minutes in qualifying, that's a huge amount of time. So if we can turn around and now get that down to sub-minute, which is possible, you're now limiting yourself on what data you have. So we work with people like Qualcomm. Well, we're working with them on some 60 gigahertz wireless transmission, which, again, getting a little bit techie, most of you will probably get annoyed trying to connect to Wi-Fi somewhere in the world, because you normally have to wait for it to connect. After it's connected, it asks you to authenticate, whether it's a portal or not. So if you think about a car that's doing approximately 60 mile an hour, 100 meters away, by the time it's done the 100 meters, not only have we connected the car, we've done the authentication handshake, and we've downloaded somewhere in the region of 3 gig of data in 100 meters at 60 mile an hour. So not something you tend to need to do, I know, but it's some of the things that we're always trying to look at doing. Now, in the future, whether that's some technology we can start to use so that actually if we're on a train, we're not all going, oh, I've lost my data connection and everything else, so we can start to learn and benefit from that. I would expect that to be something that, with Qualcomm being inside nearly every one of our mobile phones, it's something that probably improvements we'll start to see. Once we've got that data off the car, we've got roughly 30 sets of eyes. I said 60 people earlier on, but realistically, half of those are actually looking after the car from a physical point of view. Roughly half of them, and it's not an exact science at the moment, but roughly half are looking at the data. Those people want the fastest possible access to that data. I used to have a strange issue where basically I had 30 people at the track looking at data would say, I can look at data in X minutes. When I come to the factory, it takes me hours. And trying to explain to them the fact that there was 30 people at the track or 600 in the factory trying to look at the same one file, they weren't necessarily caring the fact that that was an IT issue, they just wanted it fixed. So over the last 2 seasons, we moved to all flash from pure storage, both track and factory. This now gives me the same level of speed and performance and reliability in both places. Nobody now cares, nobody talks to me about data, they just access it. Not only can they now access it in the same way, actually they can get it faster, more reliably. So they can actually look at more data, they can make decisions faster based on data. The issue at the moment is the quantity of that data is almost too much for those 30 people. So what we then do is we take the same data we just downloaded from the car and we transmit it across the world. And we have between 30 and 300 people on a Friday will be looking at data from the car, approximately half a second behind. And I'm saying approximately just because of the different systems and speed of light. If I could change that, I'd be a wealthy person, but there's a limitation on how quickly I can get it across the world. Another 30 to 300 people that are looking at that data, trying to help make informed decisions. If I say that we create around about half a terabyte of data during a race weekend, it doesn't sound a huge number. I know some of you going, oh yeah, we've got petabytes or we've got terabytes. If you imagine though that those cars are actually only on track for approximately 20% of 10 hours of possible running time. Most of that's the race. The rest of the time you see them go out for 3 or 4 minute stints. Those 3 or 4 minute stints actually create the same amount of data that I create in a race. The limitation again is coming back to the standard ECU. So the amount of data I generate in a race for 72 laps over an hour and a half, the same amount as I get for 3 or 4 laps. The fidelity of data is obviously a massive difference. What we're choosing to record, the frequency of that data. On here it says about the 300 sensors per car. Actually, we changed the number of sensors between a Friday, Saturday, and a Sunday because a sensor is weight. Weight is lack of performance. So now you're trying to weigh up, do I want more data? What quality of data? How frequent is that data? Is it for performance or is it for reliability? If you haven't got the data in the first place, you can't start to work out what's good, bad, or indifferent and what you can do without for a race. On here, I say about the 3-to-1 data reduction. This comes as a freebie for me from Pure, which is a massive benefit as far as the IT department are concerned, because half a terabyte doesn't sound a huge amount coming from the car, but if you turn around and consider that every time we go to an event, they want all of this year's data, they want all of last year's data, and as many races of this race, many copies going back as I can possibly store. With the data reduction we're getting, it means that actually I can take more data for them to look at. They've now got a more informed decision again. Coming back to data. At the track, you'll hear me say this a lot, everything we do at the track is about informed decisions from data. The factory, we're getting there. We're not quite as robust, we're not quite as far forward on that front at the moment. The 3.5 terabytes of data is the amount that we transfer back to the UK, just for the UK to be able to turn around and look at the same data as at the track. It's only half a terabyte of data that I said we produce from the car. There's lots and lots of other data that we produce, whether that's video, audio, Excel and Word's not going to create a huge amount of 3.5 terabytes, I know, but there's a huge amount of data in there. And also SQL databases, AD replication, all the other SQL servers that we've got, all the other infrastructure that people just expect to work. And it has to be at the track as well as the factory, because if we have a failure of the link, they need to work autonomously at the track. Back in the factory, the virtualized estate actually is both the track and factory now. We used to be a far higher level of virtualization at the factory, at the track than the factory. We've caught up over the last 12 months or so. So realistically, if you went back 10 years, the 2 racks I told you were probably 3.5 racks of equipment. It was all physical servers, and we were limited by the fact of what CPUs and what we could run on each of those physical servers. Without virtualization today, we wouldn't be as advanced as we are with our data capture, our data analysis, because there's a number of pieces of software now that we virtualize to allow more simulation at the track. The 45 terabytes a week, now it's a bigger number. It's a number that some of you might think is actually a sensible number to be saying that we're a data-driven business. Majority of that 45 terabytes comes from the CFD. You can see a picture on there of an example of some of the FE and the thermal analysis that we do. But if you think of 45 terabytes, we've now got a fairly big number that we've got people wanting to access, again, in a very performant manner. The problem now is actually we're reducing so much that how do you have enough eyes to work out what's good data, what's bad data, what's normal data? So we're beginning to work with the likes of TIBCO and other partners as well to turn around and actually say, right, who's a clever person in the business? Why do they need to be doing a repetitive, mundane, boring job? I was talking to a gentleman on the way down here this morning, and I said, we're having to teach people at work the fact that giving them new tools that turn around and almost make them redundant, it isn't the point of making them redundant. It's to stop them having to do boring, mundane, repetitive tasks. If we can take that away from people, they're now more enthusiastic. They want to stay working for us rather than go to another team, hopefully because we're winning as well. And they turn around now, and they're now thinking, they're using their brains to think of better ways to do things, faster, whether that's a more accurate result, whether they're just not bored at what they're doing, so they're thinking of different ways to analyze the data. It's a really important piece for us now that we've got to start looking at some newer technologies. And we are behind the curve, I would say, as a business. But one thing we're very good at is once we've made a decision on a direction we're going, we're very, very good at going in that direction as fast as we humanly can. Our limitation is actually space and headcount, money to a degree as well, but that's always debatable about whether we're money constrained or whether we're headcount and space constrained. The CFD, it's a strange one. Trackside and CFD, we're actually limited by rules on what we can do and how we can do it, and also in aero. And where we're restricted by rules, we get very, very, very clever and very, very fine at how we do that particular piece of work. How much time do you spend on CFD versus physical aero work? So if you think, I don't know how many of you know the rule, but there's this equivalency line basically where we can have X hours of wind tunnel time and no CFD, X amount of CFD, no wind tunnel time. And where's the right place on that line? How good are your correlations between your CFD and your wind tunnel and your simulators and your dyno and track? How confident are you that if you do some CFD work, that the data and the answers you get actually correlate to the full-size car? Could you turn around and not have physical? Could you have less physical and more CFD? Do we need more physical because we don't trust the CFD? Or the dyno says it's slightly different? Or the simulator says it's slightly different? So we're always looking for ways to refine the results and really understand and correlate the results. On the screen, one of the things that always amazes me is the number of different ways you can look at the same piece of data. We've just started to build up our data science practice in the office, starting off actually in our strategy group. They're probably the most, they're the furthest forward at the moment as far as understanding how they want to look at data. And the funny thing is about that group, they're looking at data that all the other 11 teams have. 10 teams, sorry. All of those teams have the same data, and we're trying to work out the best way for us to turn around and understand that data and infer strategy better than the other teams to make the better decisions at the track. Real time, their issue is, actually, I can't give them enough compute at the moment, close enough to them at the track, to be able to recalculate what's going on in real time. So they're putting pressure on me to turn around and try and improve that. So we have the same people in the factory that have got a bit more compute. Not enough as far as they're concerned, but I think if I gave them the biggest supercomputer in the world, they'd still tell me it wasn't enough. Trying to make those data-driven decisions is critical. We do that at the track. The factory, we're really learning. We're quite immature. We've got huge amounts of data in our PLM and our ERP systems. And at the moment, do you know how people make decisions? They export it to Excel and take it to a meeting. So there's a lot of work going on to try and give them new tools. So we're working with TIBCO on a few of those areas to try and show people the art of the possible. Without us having to, what we used to do was we had a software department, we'll be trying to write a visualization tool. Let's just go and grab something off the shelf, use somebody else's knowledge and expertise at what they're doing to visualize that data, and actually use those software engineers to really improve how we're analyzing that data. The factory itself, there's 8 buildings on site. We used to be just one building many, many years ago. We're 800 plus employees to get 2 cars to go around a track that you lot see every week or other week. It might seem a little bit strange. Realistically, we manufacture 2 cars. Those 2 cars are a prototype, though, every week. So 335 hours, a product evolves. It's actually sometimes less than that, because that's working on the best case, which is we've got a week's gap in between races. Like this weekend, there's no race. So if you think about a back-to-back race weekend, we do change the car between events. Would we change? Depends on the track, characteristics, type, the car, maybe the performance of the last event. A great example of this one would be we didn't have the best races at Monaco and Singapore and a couple of the high downforce tracks. So at those tracks, we learned a huge amount, because what we did was we had a benchmark to try and say how much better could we get. When we're actually winning the races, it's hard to know how much better you could go, how much further you could push yourself. How much finer did the result or the strategy or the data need to be the best still? Actually, if we haven't been the best, that's something we've got a benchmark to go for. So we're beginning to do more work around Tyre Simulation. One of the things we're beginning to do with TIBCO, actually, is we used to write our own tools to turn around and analyze software regression. So we're writing our own software tools in-house. Has that tool actually done what it's meant to do? Have we written in a change to our maths models, whether it's around tyre or vehicle or engine simulations? And has it changed the result? Should it have changed the result? Did it change it and it shouldn't have? We changed it and we got the wrong result. So rather than us actually having people now writing code to check our code, we're actually using some resource and software from TIBCO to turn around and actually do that for us. So now those guys can actually get on with writing the new version of the code. The code that we've been trying for the last 2 or 3 years to bring into fruition is actually going to appear for next year now, because we're able to divert resources to work on the work we need them to do, rather than actually just writing software to check what they're done. It says on here 363 days a year operation. Yeah, we're given Christmas Day and New Year's Day off. The rest of the time, basically, if you're on the wrong shift, you will be in Boxing Day, you will be in bank holidays, you will be in those other nice days you'd like to have off. One thing I haven't got many stats on here for is our driver in the loop simulator and our dyno. They're critical for us these days. In 2008, 2009, to try and cut costs, the FIA brought in rules to stop physical track testing. So we very rarely now send a car out rather than for racing. We'll do a few filming days for our sponsors and our partners. And we do 2 in-season tests, 2 tests at the beginning of the season, and then the young driver and tyre test at the end of the year. Other than that, we have to rely on simulation to make sure that what we take to the track at the next event is hopefully the best car, but also that we turn up with it being the best car rather than learn during a Friday. This is all done under the watchful eyes of many of you by the way your hands went up. There's an interesting point about this slide, which it's not immediately obvious to the naked eye. All those numbers on there, who owns the data about all those people? It's not us. So we don't really know about any of those people on there. We turn around and we post on Facebook or Twitter or Instagram or wherever else. Yeah, we get some likes and everything else, but actually we can't communicate with those people because Facebook decides if we post, which one of your posts does it appear high up on. Those algorithms are owned by them, not by us. One of the reasons we've created our own app is for us to turn around and actually start to get some information where we can turn around and talk to you, the real fans, rather than the number of people that at some point, at one point in time, have actually liked a Facebook page or followed us on Twitter. The data behind this is really important for us because it's the way for us to communicate with the real fans. Whether it's the fans of the teams or the drivers, that makes no difference to us. It's a critical set of information for us to try to understand over the coming years so that we can really turn around and actually, what data do you guys want to see that we've got? Some of it's limited by FIA rules about what we're allowed to do. So we're not allowed to, for instance, put live telemetry up onto our website. We could do, but we're not allowed to by regulation. We're hoping some of those will change over the coming months. Future technology in F1, some of this slide actually. So machine learning, AI, deep learning. We've actually got a brand new department being created in the office to turn around and actually focus on this and a number of other technologies because we see those as the differentiator if we get them right over the next couple of years. There's no point us trying to do it ourselves. We're going to have to partner with other people because we can't afford to have a data science team the size of maybe your Facebooks and everywhere else where they've got huge teams of people. So partnering with the likes of TIBCO and other people where they've got those data scientists, they can help us to try and understand our data better. I put 3D printing on here, and it was quite a funny one because everybody turns around and goes, yeah, that's new. We've only been doing it for 15 years. What's the difference is this year is the first time there's actually 3D printed parts on the car in a race. This was the first year we've done that. For many, many years, we've had them in tests. We've turned around and stopped manufacturing carbon or metallic parts in wind tunnels and other physical areas, and actually we've been 3D printing those for a while. But actually structurally sound enough parts to go on the car this year is the first year. So there are important advances there. Automation. Yeah, there's an amount we can save ourselves time and effort. The more important couple of ones for me here, AR and VR. So I personally don't think the VR piece will be a huge takeoff for us as a business. Probably the simulator for the driver in the loop simulator is the one place. Because if you think of your best and most favorite driving game, I was going to say some names of consoles then, but either way, pick your favorite one. Now put that on steroids so that basically you've got a 360-degree view, proper LiDAR scanned versions of tracks and photorealistic imagery, and then take that on another year or so's worth of what you'll see in the gameplay. That's what we have in the factory for the drivers. Then we put all of our scientific models in the background. So the driver, we can actually change the tyres in the simulation, and they get the real change in feel and drive of the car. Augmented reality will be the thing that we'll use the most of. Simply for us to turn around at the track, somebody's redesigned a part, they'll be able to turn around, hopefully using their favorite nondescript mobile phone or tablet, they'll be turning around and they'll be basically using that to augment basically the new design over the physical part of the car at the track to see whether they can use it. That's it from me, and I think I'm just about on time. I don't know if there was any chance for questions. I don't know. Nobody's around to ask that either, so thank you very much.